Alright, in this video I'll be solving systems of inequalities. So let's go ahead and get started. So it says here, to graph an inequality, graph the equal case, use a dotted line for less than or greater than, a solid line for less than or equal or greater or equal. Use a test point to determine on which side of the line to shade. Usually we'll use 0, 0 unless it's on the line. So on the first equation, we're going to graph y equals 3/2 x, 3/2 times x minus 4. And because it's a greater than, there's no equal symbol, we're going to use a dotted line. So let's go ahead and start it. This is in slope-intercept form, so we'll start at 0, -4. We're going to go up 1, 2, 3, and write 2, because our slope is 3/2. I'll do it one more time. 1, 2, 3, write 2. And so here's our line. Whoops, and we know this needs to be dotted. So it looks like this. This is y equals 3/2 x minus 4. So now let's test 0, 0. So what that means is plug it in. We have 0 is greater than 3/2 times 0 minus 4. Well, that's 0 is greater than, this will be 0 minus 4, which is -4. So 0 is greater than -4, so that's true, which means this point is a solution. And so it turns out that so will all other points on this side. So if 0, 0 is a solution, every other point on this side will be. So I'm going to shade with this here. You could color it in if you wanted to, but you get the idea here. This is any point in this region is a solution, and notice the points on the line are not solutions. This is just a boundary. If you pick a point over here or a point on the line and you plug it in, it will not make the inequality true. And so this is our solution. All right, let's move on to number 2. And it's really the same process, except for in this case, I could solve for y and use the slope and the y-intercept, but it's probably easier to just use the intercepts, because this is in standard form and these two numbers divide into 8. The intercept method works quite nice here. If I let x be 0, I get 4 times 0 plus 2y is equal to 8. Now remember, we're solving the equal case. I guess I should have written 4x plus 2y equals 8. And we're going to use a solid line, since we do have the equal symbol here, which indicates that we want to know when 4x plus 2y is also equal to 8. That'll be part of our solution. So here, when we're finding the x or the y-intercept, we let x be 0. We're going to get 2y is 8, so y is 4. And if we let y be 0, we'll get 4x equals 8, and so we'll get 2. So when we choose y to be 0, we get x is 2. So 0, 4 is here, and 2, 0 is here. I'm going to draw a solid line. Try to make it straight. This is where 4x plus 2y is equal to 8. We should label the line. And then we're going to test 0, 0 again. Notice it's not on the line. So test 0, 0. So we have 4 times 0 plus 2 times 0 less than or equal to 8. Again, we're using the inequality when we do the test. We're going to get 0 is less than 8, which is true. So again, we're going to shade on the side of 0, 0. 0, 0 is right here. So that's going to be all the points in this region here. And notice the line is part of our solution as well. Any point on this line will make the equation equal, and any point over here is going to make it less than 8. And so that's our solution. Every point here and every point on the line. Alright, so now we're going to graph a system. And so it's a good idea to have two colors, which I will use, because we're going to be graphing two lines and basically doing what we did here twice. Using two colors makes it a little bit easier. Alright, so first of all, I'm going to graph y equals negative 1/2 x plus 4, and we're going to use a solid line because we have greater or equal. And I would just remind you, we're using an intercept of 0, 4, the y-intercept, and we can either go or use m as negative 1 over 2, or we can use it as 1 over negative 2. Normally I use this here, but sometimes it may make sense to use the other form, but only the numerator or denominator is negative, not both. So let's go ahead and start at 4, and we're going to go down 1, right 2, and I'm going to find a few points. Down 1, right 2, down 1, right 2. In fact, it wouldn't hurt to go up 1, left 2, up 1, left 2, up 1, left 2. And again, this is a solid line. I like to draw a lot of points so I can draw myself a nice straight line, hopefully. Now here it's more important to label your line. You have y equals negative 1/2 x plus 4. And now we need to do the test. We're going to test 0, 0. So 0 is greater or equal to negative 1/2 times 0 plus 4. That 0 is greater or equal to 0 plus 4. 0 is greater or equal to 4. Well, that's certainly false. 0 is not greater than 4. So we won't shade on this side. We'll shade on the opposite side. Alright, and now we'll do the other one. Here we're going to graph y equals 2x minus 1. We'll use a slope of 2 over 1, and this time we're going to do a dotted line. So let's go ahead and we'll start at negative 1. We'll go up 2, right 1, up 2, right 1. Notice our intersection's right there. Up 2, right 1, up 2, right 1. So, dotted line. And now you could go down. It's rise over run. Down 2, left 1, down 2, left 1, down 2, left 1, down 2, left 1. If you want to get, again, a better, more points to use to help draw a straight line. Alright, so this one is y equals 2x minus 1. And again, it acts more as a boundary. And we want to test 0, 0. Notice 0, 0 is not on the line, but it is close. So again, we'll test 0, 0 since it's not on the line. We get, and again, we're using the inequality when we do this. It's 0 is less than 2 times 0 minus 1. 0 is less than negative 1. Well, that's false. 0 is bigger than any negative number. It's not less than a negative number. And so we won't shade on the side of 0, 0. We'll shade on the opposite side. So we're going to shade this way. Alright, so you can see where the overlap is. Those are the solutions to both inequalities. And so I'm going to use a dark pen or black pen to make my boundary. So my boundary is here. It's this dotted line. which means this line, the points on this line are not part of the solution. However, this line is solid, so we'll make this solid. Every point on this line is a solution to both equations. And then you can see that the part that is in here is actually our solution. So one of the things you may want to do, it's a little bit of a challenge to do this answer in my math lab. I've made a video to show you how to do that, and so I'll post that as well as this video here. Now I do want to mention something here. This point of intersection is a point that we normally need to have. In this case, you can see it's 2, 3. And so if you were asked to find that point of intersection, it ended up being on both lines at a nice point. That doesn't always happen, but in this case we have it without doing any extra work. But sometimes we may need to do some work to find that point. Basically what we would do is solve this system here. Y equals negative 1/2 x plus 4, and y equals 2x minus 1. You could actually solve this system by setting these two equal to each other, since they're both equal to y. And you'd find x, and then you could go back and find y. But we already know it's the point 2, 3, x is 2 and y is 3. But that's how you would do it. Let's go ahead and, I think I'm going to go ahead and stop the video here, and I'll do a second video for problems 4 and 5.